say that, Freudian slip. We've got thunder and lightning crackling about the area, so hopefully we get through the webinar without any disturbances to the power. If it all goes pear-shaped, you know what's happened. We've had some problems with the weather. So I'll tell you a little bit more about Deirdre in a moment, but just firstly a little bit of housekeeping and a little bit about Weed Smart. Weed Smart is an industry initiative where we get the chemical companies and seed companies, and they've put some money together, as well as GRDC contributing some funding to come up with a single consistent message about managing herbicide-resistant weeds. So it's about awareness and it's about solutions for herbicide-resistant weed management. Ari is managing the Weed Smart campaign at the moment with Lisa Mayer at Ari heading that, and we've been looking after it for a bit over 12 months now. There's a lot of information on the Weed Smart website. If you haven't been there already, go and have a look. It's aimed at being very practical and focused at growers, so that growers can get a lot of good, simple, practical information out of it. Okay, so just a little bit about today's webinar. The way it will run is I'll be here in Wagga with Deirdre, and it'll be like an interview style webinar where we'll both be speaking a little bit, but Deirdre is the expert, and so we'll hear mostly from her. In terms of the running it, you'll have a box on the side of your screen there with some different things in it where you're all muted at the moment, so we can't hear you. But you might like to minimise that box by clicking on that orange arrow so that it's not in the way of the slides. If you'd like to ask a question, and please do, it's really good if you ask lots of questions as we go, just click on that arrow again, maximise that box and type a question into the question panel, and Kate from Coccinall will forward that question on to me, and we'll make sure it gets answered. Hopefully we can answer most of the questions. Sometimes we get a little bit swamped and we don't get to them all, but we'd like this to be interactive as possible. So please put your questions forward, and we'll have a swing at as many as we can get to. If things do go pear-shaped for you at your end, there's two ways of you overcoming that. One is to go to that web link there and enter that webinar ID. So if you have a pen and paper, you might like to write that down right now, or you might like to write down Kate from Coccinall. Kate Lay is helping us out today, and that's her mobile phone number there. She can troubleshoot for you if you happen to have a connection problem and you'd like to get back on. So we're just about done. We've had 120 odd people register for today's webinar. Our maximum is 100. Hopefully we'll be close to that. Let's just have a quick look. We've got 47 of you out there at the moment, so it's great to have you all along. So without further ado, I shall hand over to Deirdre Lemerle. I'll just get Deirdre's presentation up and running. So Deirdre Lemerle is the Director of the Graham Centre at Charles Sturt University here in Wagga Wagga. She's a Professor of Agricultural Innovation. Deirdre's been here at Charles Sturt Uni for 10 years, and prior to that had 25 years with the DPI, all in Wagga. So 35 years in the Wagga area, and a lot of her work in the early years, and when she was doing a lot more research back then, was about crop competition. Today we're talking about crop competition and about how to maximise competition and get it working for you as part of your non-herbicide weed management. So welcome Deirdre, and I'll hand over to you to go through a few slides, and I'll interject with questions as we go.
Okay, thanks Peter, and it's great to be here and to be able to talk to the growers about some useful tactics that we have that can help control herbicide resistance populations. You'll see on your screen there a picture of annual ryegrass, a really healthy annual ryegrass on the right compared to one that's been controlled with a herbicide on the left, growing in a lupin crop. Now, the lupin wheat rotation was one of the first places that we saw herbicide resistance developing, and that's been a major push for the need for alternative non-chemical control tactics such as weed crop competition. Before we get into the details of how we can make crops more competitive, we'll just have a look at some of the statistics of where we're at with herbicide resistance. And here's a slide that shows you that resistance started to develop in the late 70s, early 80s, and how that has progressed over time. as herbicide use continues, you will see that these levels of resistance will continue to rise and limit the number of herbicide options that we have for weed management in our cropping systems. Currently in Australia, we have a major problem with glyphosate resistance, and you would have heard a lot about this in the last few years. Glyphosate is really important for the sustainability of our grain production systems because it's an important component for the success of conservation agriculture, and that means reduced tillage or no tillage and stubble retention. You'll note there that in this slide that annual ryegrass first had resistance to glyphosate in 1996, and by May 2014 the number of confirmed populations was up to over 500, and by now that's probably up into the 600s. There are other weeds that are developing resistance to glyphosate, as you can see on the screen, and so we're really looking at a serious problem about the sustainability of herbicides into the future, and that's why we need to be looking at alternatives, a whole range of tactics that we can use to address the problem of herbicide resistance and continue to be able to produce higher yields of our grains, but with less dependence on herbicides. So what I'm going to talk about today with you, I'll have a discussion with you and Peter about how we can use crop competition to suppress weed growth and maintain crop yield. So there are two key factors there. We want to maintain grain yield in the presence of weeds, but we also want to suppress weed growth and seed bank to replenishment. So there are four pretty easy tactics that can be used with a little bit of planning to both suppress weed growth and maintain crop yields. Firstly, we've got choosing a crop species. There are differences between our winter crop species in their competitive ability with weeds, and we'll talk about that in a bit more detail in a minute. Secondly, within each crop species, there are differences in the competitive ability of different varieties. Thirdly, we can manipulate the crop seeding rate. Generally, as seeding rate increases, there's an increase in weed suppression. And fourthly, changes in the row spacing of the crop can influence the competitive ability of the crop. On the list there below those top four points, there are four other points which are all to do with good agronomy to maintain strong competitive ability. And this should be just normal practice, best practice. So high quality seed, correct seeding depth, fertiliser placement, correct fertiliser timing and placement, and the correct use of other pesticides. And the aim there is to maintain good crop emergence and early vigour just through good agronomy. So first of all, we'll talk in a little detail about the differences in crop species ability to compete with weeds. And most of the early work that's been done is with annual ryegrass as the weed, because that's our most important weed species, and that's where we have the high levels of herbicide resistance. So we did some early work in the late 90s and early 20s, comparing the competitive ability of different crop species. And on the screen you'll see the crops on the left, which are strongly competitive, compared to the crops on the right, which are much more weakly competitive. And you'll see cereals like rye, oats and barley, strongly competitive compared to poorly competitive pulses, grain legumes such as lentils, chickpeas and field peas. Canola tends to be sort of middle of the road in competitive ability, but within each of these crop species there are large differences in the competitive ability between different varieties. Generally, the crop species and the varieties which are strongly competitive have early crop emergence and early vigour. They cover the ground quickly and they can suppress early weed growth, and that's a critical factor.
Tell us what's going on in this photo here, Deirdre.
Yeah, this is some work we've done recently looking at the competitive ability of canola varieties. And on the left we have a row that's been sown, a lot of different canola varieties that have been sown with annual ryegrass, and on the right is a weed-free, are the weed-free varieties. You'll see in the foreground that the canola variety at the front is really overwhelmed with annual ryegrass, whereas the canola variety at the back, on the left, you'll see that it's quite vigorous even in the presence of annual ryegrass. So this demonstrates within canola a big difference in the ability of the crop variety to suppress weeds. And we found that the hybrids can suppress weeds by up to 50% more, the hybrids, rather than the non-hybrid types.
So hybrids are 50% weed suppression compared to normal canola?
Yeah, that's right.
And I guess that begs the question, is a hybrid canola as competitive as, say, one of the less competitive wheats? And it's probably a question you can't really answer, but would you speculate to suggest that some of this hybrid canola might get close to wheat? Yeah,
the sowing of the canola early is really important to establish good ground cover, and so early vigorous varieties will be strongly competitive compared to wheat. I mean, obviously, the relative competitive ability of different crops and different species, different varieties within crops is strongly influenced by the farming systems in which they're grown, the environment and the general agronomy used by the grower. But a rule of thumb is that the strongly competitive canola varieties probably would be as strong as would be as good as the strongly competitive wheat varieties.
Right.
And there is some work looking at improving the competitive ability of wheat varieties, which we'll touch on a bit in a minute. Okay, well let's move on. In fact, that leads us to our next slide.
Beautiful.
Here we have a couple of wheat varieties. On your left is a variety called
Oh, catch 'em.
How do you say that?
You're obviously from the East Coast.
That must be a WA variety.
Wow.
And you can see that it's absolutely totally overwhelmed with annual ryegrass, whereas on the right, UA40, which is a selection from the University of Adelaide, and some work done by Gurjit Gill and Greg Rabetsky at CSIRO, have been looking at developing wheat varieties that have really strong early vigour and strong weed suppressive ability. And so you can see the really extreme differences that you can have in the competitive ability of a strongly competitive and weakly competitive genotype.
Yeah, so that's some plots from a trial that I did in 2011 in Eridu, so Eridu sandplain soil just east of Geraldton in Western Australia. Yeah, Greg Rabetsky bred the competitive cultivars through recurrent selection for vigour, and then handed some over to Gurjit Gill and Michael Zerner, who interrogated them a lot with research, and they sent a few varieties to me to just try in the field. And wild catcham, to put it in perspective, is our most uncompetitive wheat variety that we have in WA. So it's sort of comparing the best with the worst there. So not the fairest of comparisons, but wild catcham at the time was the most commonly grown variety in WA. And in this situation, the UA40, that big leafy variety on the right there, it reduced the ryegrass seed set by about 70-odd%. So just cultivar did have a huge effect.
When we screened a broad range of varieties in the late 90s, we found that there's 100% difference between in yield loss, 100% yield loss in some genotypes compared to no yield loss in other genotypes, when we looked at a really broad range of wheat varieties from across Australia and from overseas.
So there is always two sides to it, isn't there? There's the side of how much do you reduce the ryegrass seed set, but there's also does the more competitive cultivar do yield well in a weedy situation? And you're saying that in some situations the uncompetitive varieties virtually yielded nothing.
Absolutely. And just to reinforce that point, it's really important to consider both crop yield and weed seed production in this equation of crop competition.
Yeah. So keep those questions coming in out there. I don't think we've had any questions yet, but if any questions come up, type them into the questions box and Kate will forward them on to me and we'll tackle the questions as we go.
Okay, well let's move on to the benefits of increasing crop seeding rate and the impacts of row spacing on crop competition. Okay, here we have some work done by Dave Minke in WA, which shows very clearly the benefits of both narrowing row spacing and increasing crop seeding rate for weed suppression.
One of the most perfect data sets you could ever do. A bit of cherry picking in there on our part. But
and these sort of results have been generated across Australia. While this is WA work, there's been research in Queensland with Steve Walker and Michael Widerick's group, and with our group down here at Wagga Wagga, where we've come up with similar results.
So you've produced data sets a little bit like this one in the past, Deirdre?
Yeah. Where we've shown that, let's go for wider row spacing. So row spacing on the right, from the grey at the front to the red on the right, and you can see that as you increase row spacing across the board, across the seeding rates, the number of seeds of ryegrass or seed heads increases. If you look at the grayscale, as you increase seeding rate to the left, as you reduce seeding rate, you get huge quantities of annual ryegrass seed compared to where you have the high seeding rate and the narrow row spacing, which is the shortest box at the front. So that is a fantastic demonstration of the benefits of both increasing crop seeding rate and reducing row spacing for weed management. I'll just move on to another slide that reinforces that.
I'll just interject for a minute. We've got a question from Lou asking, is UA40 going to be released as a commercial variety? And UA40 itself, no, but hopefully one day germplasm from Greg Rubetsky's breeding program will find its way into some breeding of other companies. So really those varieties we didn't ever think that they would go straight on to become a commercial variety. They were really just demonstrating a concept, and they certainly did. And the other part of that research was that the leafy varieties shade the soil and reduce evaporation early as well. So it wasn't all just about weeds, but that's more of a question for breeders and so on. Are they going to head down the path of more early vigour?
When we started doing this competition work 20 years ago, we had a lot of discussion with breeders about the potential to breed for competitive ability, and they said, no, we've got to focus on other aspects. But now that herbicide resistance is here, there's much more effort into breeding for competitive ability. So we'll just move on to the next slide now. We've discussed the agronomy of row spacing and seed rate. Here's another slide which shows that if you increase seeding rate, you clearly reduce weed seed production.
That's one in the absence of herbicide, that one, so it's a large ryegrass seed set. But there's plenty of data like this around the country, Deirdre, that shows increasing seeding rate. And what's your rule of thumb for this one?
Generally, by doubling the seed rate, the crop seeding rate, you can halve the weed seed production.
And have you measured that in the number of species, or mainly ryegrass?
Mainly in wheat and with ryegrass. Yeah. But there's probably a need for some future work to look at the impact of increasing crop seeding rate of different crop species, but also on different weed species, because obviously they have different growth habits and phenologies, so it's important to get that data across a broader range of crops.
So this one here, it's not quite halving the seed set from 40 to 80, but in this case it was more like moving from 40 to say 100 odd kilograms or 120 was what would halve the seed set. But that is in the absence of herbicides.
Yeah. And these sort of data, we can talk about sort of rules of thumb and principles, but to fine-tune the recommendations, the research really needs to be done at the farming systems level, so that people can get a more accurate estimate of the values for their particular region, for their genotypes and their cropping systems and environments. So I'll move on to another bit of work that's come out of WA from Glenn Reithmuller, based at Meriden, I think.
That's right, you can pronounce that one.
Yeah, that's easy. He's done a lot of work. He's actually an engineer, but he works with plants, so he understands biology. Glenn's done a lot of work over the years looking at different conservation agriculture machinery and impact on crops and weeds. And more recently, he's been looking at the impact, more recently, in a 27-year trial.
Last 27 years, he has, yeah.
Well, some of us have been around that long. It seems quite recent.
28, I suppose.
He's been looking at the impact of wider row spacing on ryegrass seed bank, and this is a long-term trial. I mean, 25 years, what a luxury to do such long-term work. And you can see there that at the wider row spacing, there really is a huge increase in the number of ryegrass seeds compared to the narrow row spacings of 90 millimetres.
So just to put this one in context, they did those row spacings back on the same plots every year for 27, now 28 years in a row, and this is with normal sort of crop herbicides, which has changed a little bit over the years as different herbicides have come to the market, obviously being such a long-term trial, but just showing that compounding effect of reducing that seed set of ryegrass every year. And I think, I don't know what the rule of thumb here is, Deirdre, but I would guess it's something like halving the row spacing, half the seed set, or thereabouts.
Yeah, again, it will vary with crop species and season, but something like a 50% would be a good guesstimate, I'd say.
And it doesn't sound like much, 50%, but what you can see here is if you get 50% ryegrass seed set control every year in a row, the compounding effect of that just gets that seed bank eroding rather than allowing it to sustain.
And when you combine that with other weed control tactics and where the herbicides work correct herbicide performance, you also get an improvement in the herbicide performance when you combine it with these non-chemical control tactics.
So we don't have slides on it, Deirdre, but do you have any evidence that springs to mind from trials that you did where you've got better herbicide control, where you had better competition?
Yeah, we did work here about 10 years ago, and also Steve Walker at Toowoomba in Queensland. We were both looking at the interaction between herbicide performance and increasing crop seeding rate. And we both, in totally different environments, showed that increasing the seeding rate of the crop strongly improved the reliability of the herbicide performance, and that's relevant to both where herbicide performance is decreasing because of early onset of herbicide resistance, or when environmental conditions are such that you don't get such good herbicide, whether it's hot or dry or whatever.
I saw exactly the same thing, actually. If I just go back to this slide here, this is actually a trial of mine, and that slide there is in the absence of herbicides, and we also had plus Sakura in this case for ryegrass, and where we had 40 kilograms per hectare seeding rate, we actually got 95% control with Sakura, which was fantastic. But where we had 120 kilo per hectare seeding rate, we got 99% control with Sakura.
Yeah.
So increasing the competition took Sakura from a 95 to a 99% herbicide.
Yeah, and you might even see higher levels of that kind of synergy depending on the environmental conditions and the level of weeds that are there. So it's really, really important to look at those sort of synergies between culture control and improving herbicide performance.
Now, there's a question from Andrew Boltby has come in, and it's for Deirdre. Did David measure the effect of trifluralin rate on narrow row spacing and suggest that the 2.5 litre rate might be a bit too high on narrow rows? Deirdre is pointing her finger firmly at me here. Now, it's a good question, Andrew, and my experience with that, I have some experience. There are some growers using 7-inch row spacing in the Minginoo area, and interestingly, one particular family, the Prestons, have got 7-inch row spacing on a bar, and they find that the faster they go very fast, 10, 11 k's an hour at 7-inch row spacing, the safer their trifluralin is, and they're using full rates of trifluralin, but I don't think they are using 2.5 litres. I think they're using in the 1.6 to 2 litres per hectare. So there is a safe trifluralin rate for every bar, but there certainly are growers out there at narrower row spacings that are using quite a bit of trifluralin. Obviously, it comes down to trial and error with that particular bar. And here's a note from Andrew Story, who's listening on the phone. Can you both get closer to the microphone?
Sorry, Stars.
How about you turn up your volume, old man?
Can I just add to that trifluralin story that in the herbicide tolerance trials that we've done here, we found that even with an up to 40% reduction in emergence due to trifluralin damage, that often that didn't translate into final grain yield because the wheat particularly in wheat, is able to tiller and compensate for early reductions in emergence. So it's not a simple story with the trifluralin.
Yep.
Can we move on to this?
We can. Yeah.
How are we going?
We're going very well.
Oh, good.
25 minutes down.
Okay. The slide that we're looking at now is showing on the left wider row spacings. That is, well, not super wide row spacings, but wider than the 15 on the right. And again, this is one of your slides. I think we've covered this probably.
We have. I guess it really did actually show a north-south, and that photo was taken towards the middle of the day, and it really does just show that shading effect that you get from the narrow row spacings. And really, I think, Deirdre, you might comment on this. I mean, we talk about competition, competing for light, moisture and nutrients. With row spacing, is it mostly about light, or is it also about the moisture and nutrients as well?
I'd say it's a combination of both. I mean, the wider row spacings, the availability of moisture in the interrow, but obviously light, competition for light would be important. It's not just competition for water, competition for nutrients is important. Also, the impact of stubble at wide row spacings would have an influence on things as well. So just to finish off on wide row spacings, there's a publication that's written or published last year, and it's a review of the impact of row spacing on winter crops in Australia, and that was done by Brendan Scott, Peter Martin and Glenn Reithmuller, and they reviewed the literature from across Australia looking at both weed-free and weedy crops, and they found that in weed-free crops, for every increase in row width, every inch increase in row width, there was a 1% reduction in grain yield. And that's a very good summary of the current knowledge around row spacing. So I recommend that that people who are interested in row spacing have a look at that. It's available on the Graham Centre website at no cost.
I'd cut this particular publication around with me a lot, Deirdre. I think it's brilliant because it's a review of 89 trials in Australia, and so it's one thing to look at one or two trials here and there, but when you group 89 of them together and they conclusively say that narrow row spacing yields more, it just shows that we can grow more yield at the same time, get better competition, and that's essentially what it's all about.
Yeah, and as I had a phone call from a farmer in Roma yesterday, and he said, well, it's just like a free lunch, isn't it? You get something for nothing with just a little bit more planning, and well, that's what we want.
Now, there's a question come in from Peter Hills. At what point does seeding rate impact on yield and quality? I'll have a swing at this one as well, but Deirdre, seeding rate, firstly, let's talk about grain quality. High seeding rates, did your research find an impact on grain quality?
We didn't find any impact on grain quality. There does tend to be an inverse relationship between protein levels as yield goes up. Often the protein levels go down, but that's in weedy and in weed-free situations. We've looked at the impact of breed competition on canola quality and didn't find any impact.
What about wheat screenings? That's one that farmers always talk about, that if you go high seeding rates, you'll end up with a lot of small screened grain. Yeah,
we did a big experiment when we had the weed CRC where we coordinated across Australia an experiment where we looked at in wheat at a range of sites from Merredin across to Victoria and up in Queensland. We looked at a range of seeding rates and we measured yield and screenings, and the only site where we had a reduction in screenings, a slight reduction in screenings at the high seeding rates in the presence of weeds was in WA, at a very, very dry site.
Yep.
But over the other sites, over three, I can't remember if it was 2 or 3 seasons, but it was at least 2 seasons at each site, we didn't have any impact. And there was a lot of discussion about that at that time, and that experiment disproved that concern at most sites, apart from that one in WA, and it was probably at Merredin, I think.
And what about yield? High seeding rates and wheat yield?
Consistently over the broad range of sites and seasons, increasing seeding rate maintained crop yield in the presence and absence of weeds.
Same yield?
Yeah.
Yeah. And I've found the same thing in trials in Western Australia, and not only myself but other people that have done this research, that unfortunately we don't often get higher yield from the higher seeding rates, which is a problem because that means that we get no extra yield, but we have extra cost and we have extra grain storage and grain handling at seeding and so on. And so we don't get extra yield. By the same token though, we didn't find any screening problems in Western Australia with high seeding rates leading to screenings, except in that odd extreme situation of the extremely dry season. David Minke's trial there that we showed you before, he went up to 400 kilograms per hectare of seed and didn't even get high screenings. So so I think screenings, even though a lot of farmers would comment about it, I think nitrogen drives screenings myself, and that seeding rate has a lesser impact. And unfortunately we don't get extra yield, which leads me personally, and Deirdre you can comment on this, to my conclusion that yes, while seeding rates are a very good way of getting competition and relatively easy to adopt, narrow row spacing gives us more yield and competition.
Yeah, when we were doing our work 10 years ago, it was in a time when we didn't have such good equipment and people were really struggling, particularly in the high rainfall and irrigated areas, were struggling to sow through heavy stubble, and so there was a trend to wider row spacing. These days where the equipment's improved and we can get through those heavier loads, those sort of problems don't exist anymore, and so we're much more comfortable about encouraging farmers to go to the narrow row spacing just for weed competition and to maintain yield.
Yeah.
But the weed suppression is really, really important because we want to break the cycle of weed seed bank replenishment and try and disable the weed, if you like, to perpetuate its population.
Yeah. Got a comment here from Stephen Hobbs. Perhaps we should be using a multi-variety mix, e.g. mix 2 or 3 different varieties together with different competitiveness that have the same maturity and bin grade. Is there any advantage, do you think, Deirdre, from mixing wheat varieties together for competition with weeds?
Well, I think we know we've got a good idea of which the competitive varieties are, and if they're equal in all other things like yield and quality and disease resistance, you'd go for the competitive variety. If there was a penalty associated with a competitive variety, then you might consider not using it. But really, there has been some work done on mixed populations in Europe with the organic farming movement, where they don't have any herbicides. And a lot of the early work that we did was actually with organic farmers, and they were looking at mixed populations as a way of sort of broadening the resilience of the wheat crop. But I don't know if that's still happening, so I can't comment further than that.
Good question, isn't it? Because there's a bit of talk about that with frost as well, isn't there? Could you mix up some varieties of slightly different season length and so on? And perhaps if you did have the more competitive variety that was slightly lower yielding, it might be worth having a percentage of that in the mix just to get the competition. But yeah, probably a good research question anyway.
Yeah, and I guess it might be a marketing question as well.
Yeah. Okay, we'll leave that one alone, mate. Righto, let's talk about allelopathy.
Okay, well, let's talk about allelopathy. But before we...
Sorry, you want to talk about allelopathy?
Yeah, I'd love to talk about allelopathy. I just would like to say, to finish off on that sort of agronomy for crop competition, that we do know a lot about wheat, but we don't know as much about the pulses, which is a real gap in our knowledge. Okay, now let's talk about allelopathy. Allelopathy, I know it's a difficult word to pronounce, but allelopathy means that plants exude chemicals that can suppress the growth of neighbouring plants. And we've known for a number of years that crops can suppress chemicals that could be useful for suppressing weeds to improve their yield, the yield of the crop, and suppress weed seed bank replenishment, as we've just been talking about. A lot of the early work on crop allelopathy was done when we had a rice CRC, and there are big differences in rice genotypes in their ability to suppress weeds. Following that, and Professor Jim Prattley has been leading this work in Australia. After the rice work, they looked at wheat And we had a PhD student here who looked at, Dr. Han Wen Wu, who looked at differences in wheat varieties and their ability to suppress annual ryegrass, and they were quite significant. And more recently, we've been looking at canola. And on the screen in front of you, we've got a graph that shows a range of different root suppressions. So the figure that you can see is across the bottom are different genotypes of canola, and on the axis is their ability to suppress the root growth of annual ryegrass. And so on the left, the varieties that are there have a very strong root inhibition, so they're strongly allelopathic, whereas the genotypes on the right are less allelopathic. So allelopathy is an opportunity to make the crop more able to suppress weed growth, but it's a long-term solution. It's a little bit like the work that we were talking about with Greg Grabetsky, and it would lead to breeding to suppress weed growth through the incorporation of genetic controls that influence allelopathic traits. While I say that, we've found recently, and we've just published this work, that there are differences in some of our commonly grown canola genotypes, varieties, in their competitive ability to suppress annual ryegrass. So that's a bit of work that we're currently working on, which could come up with a short-term solution in a recommendation of canola genotypes that are currently available that are more suppressive of weeds, but also a longer-term solution to potentially breed for allelopathy in canola.
So can you give us any insight into these canola varieties at all, or as to which ones may be the more suppressive ones?
We're in the middle of doing that work at present. We did publish a paper.
You don't need to show the audience, it's all right.
I don't need to show the audience, but we did show that some of those genotypes were more competitive, but it's I'd rather give that information out in a different when we publish that work.
Okay, so it's not quite published yet?
Not quite.
So the listeners can look forward to seeing a bit of a ranking of different canola cultivars in Australia that have different levels of allelopathy.
Yeah.
Excellent. Question came in from John Robertson, which is not about canola allelopathy, but asking, is there a list of rankings based on competitive wheat varieties available? And I don't believe that there is. So there's no bigger rating of our current varieties, is there?
No, about 10 years ago, we started to do a routine screen of relative competitive ability of wheat varieties in New South Wales, and I think in a couple of the annual wheat control books that come out every year in New South Wales, that there were some rankings given, but it's not happening on a broad scale, and it's not happening in New South Wales at present.
Yeah, we have made a bit of noise about asking if that could be added to the not necessarily MVT, but some wheat variety evaluation work, and they've had a bit of a try, and perhaps in the future we might see it maybe just as simple as using a green seeker to measure the early vigour.
I know there's been some work in New South Wales looking at differences in barley variety competitive ability, but there are probably other bits happening around Australia at present. GRDC has just funded a scoping study that will be looking at trying to summarise all the data that's currently available, both published and not published, on crop competitive ability in Australia. So that will hopefully come up with a guide about best bet recommendations based on our current knowledge, but it will also identify information needs where we need to do future research to establish relative competitive abilities of different, probably pulse varieties.
Yep.
So work still to be done.
Okay. So
okay.
You're driving this train.
Sorry, Adam.
We've got about 20 minutes to go, but I think we've only got a few slides. So if you'd like to put any questions in, now's probably the time.
I guess we have covered most of the ground that we wanted to cover, and I guess we're at the take-home message time and the time for some more questions if they're there. Basically, it's important for the growers to consider both the benefits and the costs of weed control tactics, and to look at the short-term costs. I know there's been a lot of discussion about the cost of increasing seeding rate and whether it's viable as a weed control option, but that's for yield. If you consider the benefits in terms of weed suppression, it's a longer-term benefit than just a short-term annual cost of increasing seed. So that really needs to be the longer-term costs and benefits of weed crop competition need to be considered rather than just annual. I think crop competition is really about management, and it can be low cost and a free lunch if it fits in with the farming system. It's relatively easy. It's a matter of looking at the varieties that are vigorous and making sure they don't have any other penalties in terms of yield loss or disease susceptibility, as mentioned earlier. The importance of integrated weed management for reducing seed bank for herbicide resistance management is critical. I think most people now are doing that. They're thinking about population management, not just this year's crop. Obviously, diverse crop rotations are critical. The more diversity you have in your cropping or pasture rotation, there are more opportunities for weed management. And the picture that's on the screen there is a picture taken by Murray Schultz from Holbrook. Now, Murray is a very, very keen conservation cropping person, but he's found that he's had to adopt a bit of burning, a bit of strategic burning in recent years to manage resistance. And you'll see a patch on the screen there where the stubble didn't burn, and you can see that it's greener, and that's because annual ryegrass has come up. So the use of strategic tillage and strategic burning, while controversial, could have a place in the integrated weed management toolbox in various parts of the rotation, depending on the levels of resistance that the growers are managing. As we know, weeds will continue to evolve, whatever we do.
They will.
Keeps weed scientists and weed specialists employed, and keeps the farmers adapting to the new challenges as they arise. So flexibility is critical, and being able to react to problems as they emerge.
Yep. Got a question from Jack Brown. Question from Stephen Hobbs, who says that Jack Brown at University of Idaho is breeding high glycosinolate varieties of mustard that can be used for weed control. Anything happening along those lines here? We did look at mustard, but we found that we had a couple of mustard genotypes in the Allelopathy work, and also in the canola competition trial we did 4 years ago. But generally, the popularity of mustard has decreased recently in our environment, particularly, and we found that we've got a range of allelopathic potential within the range of canola genotypes that we tested. So we'll keep working with that, but any opportunities that we see in the literature, we'll be keeping an eye on to make sure that if there are other crops or brassicas that are showing allelopathy, we're aware of those. But focusing on canola at this point, because that's the main crop. Yeah. So there's some good research coming out there. So,
yeah.
So we're just about finished, Deirdre. I mean, just wrapping it up, from my perspective, it seems that all this stuff didn't matter once upon a time ago when the herbicides worked. Well, if we had weeds, they'd come up in the crop and we could spray them and they would die. So it didn't matter if we had narrow rows or wide rows or high seeding rates or low seeding rates, because you could get away with poor crop agronomy when the herbicides were working well.
Yeah.
But in this day and age, when the herbicides are starting to fail, things like good crop agronomy and competitive crops is going to be paramount to the picture of our success.
Absolutely, and it's not that hard, and it can really save you a lot of money and a lot of problems in the longer term, because herbicide resistance will continue to grow. We want to keep our good herbicides because they're really economical when they work and effective. So integrating non-chemical crop competition is a really important part of integrated weed management. All
right. I've got a couple more questions coming through. if anyone else has a question, please ask it now, because we're just winding up, and this is probably your last opportunity to ask Deirdre a question before the before time is up. I think we're just about done.
Yeah,
there's no questions coming through, so thanks very much, Deirdre, and thank you everyone for listening in. Take a look at the Weed Smart website. We've loaded up some information about crop competition in there, and please support further webinars that we have. This is webinar number 4 of the year. There'll be 2 more on other topics later on in the year, so keep an eye out for those. So thanks very much.
Okay, see you guys.